answers are posted. I have the new sheet that I'm signing on. You also need to grab the 2 papers and a color when you get a chance. Ready, second? Right. Good, good? Yeah? Do you guys have any questions from the homework? Anything you want to go over about the different transformations? How they work? I think most of you are pretty good. Yeah?
Oh, are we finished with trigonometry, or is that?
Great question. No. So what we're going to be doing in this next unit is still trig, but it's not unit circle stuff as much as we're going to be graphing sine and cosine curves. Ooh, the excitement. That's what we're going today. Cool. It's how these graphs look like. Okay. So kind of taking unit circle skills and putting it onto an x and y axis thing. Yeah. Other questions on homework before we get into all that fun? All right, then quick for updates. I have been working on grading your tests. I grade everybody page 1 first, and then I grade everybody's page 2, and then I grade everyone's page 3. I am on page 5, so I'm making great progress, but I'm still not done yet. I'll have them for you next class on Tuesday, and we'll talk about retakes next week if we need to. Cool. Missing work. Okay, I think you're my only one that's here that needs to make up the test. Cool, so we can talk about that. Okay. And then 80 or higher quizzes. There's a couple of you that still need to get over that 80% mark. There's 5 of you. The deadline was Wednesday, so we need to chat, a couple of you. Cool, maybe check in with me before lunch if you know that you didn't get that 80 or higher yet. Gotta fix that. All right, so take a moment. Let's look at your new orange assignment sheet. It would help if you pulled it out. Come on, friends, here we go. All right, the orange assignment sheet. It is a pretty short unit. The test is in 2 weeks. What? 2 weeks from today, the 16th, is your test. Cool. We also have a quiz in this unit, which is on Monday the 12th. So if you want to circle or star these dates, the 16th and the 12th, test and a quiz. Okay. This unit, as I sort of mentioned, is all about graphing sine and cosine curves, these waves. Has anybody ever seen a wave like this before? Maybe when you think about sound waves. Yeah, maybe you talked about waves a little bit in physics, maybe wavelength, words like that. So we're going to be talking about in this unit. This unit is just one standard. It is all standard 3. And what you're going to be able to do with these graphs is find the graph, like what does the graph look like, and talk about its domain and range, talk about how the transformations, these A's, B's, C's, and D's, how do those change the graph. And then we have some new vocabulary. We're going to talk about the amplitude or the period, the phase shift, vertical shift. Asymptotes happen in tangent graphs. We're going to talk about some of that different vocabulary with these guys. Okay? Get excited. Did everyone get the second orange paper, the study guide? Yeah. It's a little different than what we've done in the past. You'll see that the one side is just like what's A, B, C's, and D's. You pretty much could fill that out already. You know it. Cool. The back side of it, we're going to do one in class that's very similar to it. The orange one is for you as you're studying and reviewing and practicing on your own. But it's a little bit different in the format for the study guide this unit. But don't lose it. Make sure you keep up with it and bring it to finish on test day so that you can get credit for it. Cool? All right. So take a look here on the board. This is what we're learning in this unit. Sine graph, cosine graph, tangent graph. It's really funky. Yeah, this is what we're going to be learning in this unit. And I'm hoping that you've seen these things before in sound waves and light waves. When we talk about different waves like radio waves, right? The radio stations play through the air, right? Those radio waves. Ultraviolet rays, X-rays, gamma rays, they have different wavelengths. The shape of this graph, right? As it gets wider apart, that's its wavelength. Okay, that changes. It's more on this side of the spectrum. And as the wavelength gets smaller, they get closer together, they're a different type of ray, and they do different things, okay? So we're going to be talking about what causes that wavelength. We also call it the period. We're talking about what makes that change, okay? And we're going to be graphing these by hand, okay? So if you would, start on your notes page for me, please. At the top of the white page, there's some vocabulary to start with. And the first vocab word is called the period. Okay, the period is how often the graph takes to repeat itself. How long does it take for that graph to repeat? So you're going to learn later today that this is a sine curve. Cool? And the sine curve repeats and repeats and repeats and repeats and repeats forever and ever. Okay? It is periodic, meaning that it has that like same section, the same chunk of the graph. It's like repeats again and repeats again and repeats again. That's its period. Okay? How often it repeats itself. Okay? If in physics, has anyone ever heard the word wavelength? Yeah, even maybe not in physics, yeah? The wavelength is the same thing as the period. Okay? It's how often the graph takes to repeat itself. Okay? The next two words on here, domain and range. I know you know those. What's domain? All the x values. Range is y values. Perfect. Same idea here. Couple things to remember. When we do these, we're always going to use interval notation. Okay, an interval notation is when you have like the two numbers and then there's parentheses or brackets, that kind of thing, right? Do you remember what the what order we put the numbers in? Do we go 2 to 4 or 4 to 2? 2 to 4, yeah. Make sure you always go from the small number to the big number. And we also have a difference in the symbols. Sometimes we put square brackets and sometimes we put parentheses. Turn to your partners, and you guys can partner up for me, Alejandro and Ethan, if you don't mind. What's the difference between a square bracket and a parenthesis? Discuss. What is the difference, guys? What does the square bracket mean? It includes the point. It's like a closed circle, right? It hits it, it equals it, closed, square bracket. The parenthesis is more like an open circle, cool, where there's maybe a hole or an asymptote that it never touches, okay? Or infinities, we put the parentheses for infinities, cool? So pay attention to make sure you're having small to big, and make sure you pay attention to brackets versus parentheses in that notation. Cool? But hopefully you know that, yeah? All right. So, up next, here it comes. We're going to graph our very first sine graph. Yay. You'll notice that there's a table here, and it's already completed. Those of us that did our homework, does it look familiar? Yeah? Pull out that homework for me. We're going to be using it a little bit today. Last night's homework 4.0. Take a look at the front. The top table with sine graph. Cool. Take a look at that first table. Does that match the numbers you had? 0, 1, 0, -1? Yeah? This comes from your homework. Secret code. It means there's a tardy sweep. No, I don't know what that means. I don't know what that is. But it'd be great if they stopped doing it. All right. Does anybody want me to go over where those come from? Where those numbers, the 1s and 0s and -1s come from? The coordinates. Does everyone feel good about where they come from? Because I can do 1 or 2. Or we all good? Yeah. Okay. Then I won't waste my time. All right. So, sorry. If we know where this comes from, what we're going to do is we're going to take this table and put it on an x and y axis, okay? And this is related to our unit circle, but this graph is no longer the unit circle. What I'm doing on this graph is I'm taking the angles and making them the x values, making them the x-axis, okay? The y values on the y-axis are going to be the answers I got for that, okay? So let's start here in the middle, because this is the easiest point in the world. 0, 0 is right on the origin. 0, 0 is right here. The x value, the angle is 0. The sign of 0, the answer is 0. So go ahead and put that point 0, 0. All right, next point. Pi over 2 is at 1. Pi over 2, that's the x value number. So I see here, I see pi is on my x-axis, yeah? Where would pi over 2 be? Wait, isn't he right in the middle between 0 and pi? Right? So here's pi. Right in the middle would be this line right here. Do we agree? Yeah? That's your pi over 2. Go ahead and label that if it helps you. That's pi over 2, that second like tick mark there. Second box. And his point is going to be up 1. Look carefully at that y-axis. Is this up 1? No, how much is this up? Half. Yeah, do you see that y-axis is counting by how much? Halves, yeah? So to get to 1, I actually have to go up 2 boxes. I'm going to go up to here. Yeah? Good? The next point we have is going to be pi is at 0. Pi is at 0. I see pi on the x-axis. Up and down 0 would be right there on the x-axis. Looking good so far. Our next one is 3 pi over 2. A little bit harder, but do you recognize 3 pi over 2? Have you heard of him before? Yeah, he was right in the middle between pi and 2 pi, right? Like that y-axis when we did the circle, right? So 3 pi over 2 should be right between pi and 2 pi. Well, here's pi and here's 2 pi. Right in the middle would be this line. Do we agree? Yeah. Here's 3 pi over 2. And his point is going to be down at -1. So down at -1. It's a lot all on top of itself. Make that better. Okay. And then finally 2 pi is back to 0. How do we feel with these points so far? Pretty good? Yeah? When you're ready, can you try the other side? Can you try the negatives? Like negative pi over 2 is at -1. So negative pi over 2 would be right in the middle between 0 and negative pi. Right in the middle, negative pi over 2. He's going to be at -1. Plot those additional points for me, going left and right. When you're ready, go ahead and draw that curve. Okay, draw that your very first sine curve. It's very exciting. With that sine curve, it's very curvy and rounded, not like a zigzag. Cool, really rounded. It's so pretty. I'm so excited for you. Oh, yay. What am I putting at the end of my curvy lines? The arrows. Yeah, because this graph does go on forever and ever. Cool. It's going to keep bumping up and down forever and ever, this beautiful sine wave. Okay. All right, before we go too much further, let's talk about this graph, because I just kind of threw you in the deep end on it, and you did great. But this graph is very different from the graphs we've dealt with before. Okay? But you're going to see this graph every time for homework, for notes, for quizzes. Everything in this unit has the same graph. Okay, so let's be comfortable with it. Remind me, when we looked at the y values, the y values didn't count by 1. What did the y values count by? Half. So write yourself a little note here. The y scale, we call that, is 1/2. Each box, for lack of a better word, each box on the y-axis counts by 1/2. Cool? Harder question for you. What do the x tick marks or x boxes count by?
4.
There's 4 of them to make a pi, right? Yeah, give me radians. Instead of 45, pi over 4. Pi over 4. So notice here, this is pi. Let me write this. So our x scale, the x-axis is counting by pi over 4. So each box is going to be a pi over 4. All right? And that's a really important thing to remember in this unit, because sometimes we're going to have to graph crazy things like 5 pi over 4 or a -3 pi over 4. And how do you know where that goes? It's all about counting. This is 1 pi over 4. This is 2 over 4, 3 over 4, 4 over 4. And you just count it. Okay? Here I'm saying that this is 4 over 4, but we wouldn't really say 4 over 4. What is 4 over 4 reduced to? 1. That's why we just called it 1 pi, right? But it's the same thing. It's just simplified. Make sense? Yeah? All right. With your partners, can you discuss domain and range? We'll do period together. You guys talk domain and range. How far left and right does it go? How far up and down does it go? Remember, it's got arrows on the ends. Think about parentheses versus brackets.
They don't really go on higher up or down. They still like the same way. That's why they also like the period. They probably change the line. They don't change the little side. They stay the same.
What do you guys think the domain is? Negative, and positive. It goes left forever and right forever. Do we agree? Yeah. Parentheses or brackets on infinities? Awesome. Bottom to top, range. What y values are we going to hit? -1 to +1. Can I say 1 to -1? No, it has to go bottom to top, small to big. Cool. And parentheses or brackets? Brackets. Why does it need to be brackets? Yeah, it hits and includes, those are closed points at 1 and -1. So square brackets. Cool. Sine and cosine graphs are always going to include those numbers, so square brackets on them. You math? Right. Your period. The period I said was how often the graph repeats itself, right? So I want to look at this graph. Actually, maybe I'll grab a highlighter. That'd be better. The period that we look at for sine, for like his parent function, is this chunk right here. And you use your color or a highlighter that you have and trace over that chunk. You can even label that. You can say that this is 1 period. Hello. So the period is how long is that distance? How far is it from the start of it to the end of it? How far is it from 0 to 2 pi? It's 2 pi. That is his period. That distance from the start of it to the end of it is called its period. Cool? And then that chunk just repeats itself over and over and over again. Get my highlight in here. It's not going to let me move it. The highlighted part just repeats over and over. Okay, math? All right. Let's take a look at our next graph. This guy is going to be cosine. Those of us that did homework, again, do you recognize the table at the top? Yeah, that's from your homework. Cool. If you want to take a quick glance, make sure that your numbers match what I have up here on the board. Good? All right. We're going to start plotting these points. Okay, I again start here in the middle at 0. It's not 0, 0 this time, it's 0, 1. So when x is 0, the y value is 1. At pi over 2, do you remember where pi over 2 was on the x-axis? Yeah, right in the middle between 0 and pi, right? Between here and here, right in the middle. There's pi over 2. Yeah? At that point, he is right at 0. So right on the x-axis. From there, pi is at -1. Go ahead and start plotting all these points from the table. Looks really good from what I'm seeing. Beautiful. Did anybody in here do trig last year? No. A couple people did my second and my When you're ready, go ahead and do the curve with it. Again, remember it's nice and rounded and curvy, not very zigzaggy, much more rounded. I haven't got the ones over here too. I'm hoping that already, maybe even just after these first two examples, you feel a little bit better with the graph and the scale of each one, x-axis and y-axis. It's a little weird. Hope you feel better with it though. Take a look at this. Yeah, matching you? You might notice that on my ends, instead of having my arrows just go up, I have my arrows like curved back down. I don't take off points if you don't do that, but it is important to know, does it just go straight up after those? No. These cosine waves keep bouncing up and down, up and down, up and down forever. Cool. All right. Partner time, domain, range, and maybe period. Let's see what you guys can do with that. Domain, range, and period. How often does it repeat? How much left and right does it go? How much up and down does it go? Domain and range look great, guys. What's our domain? Negative infinity to positive infinity. Good. Left and right forever. Guess what? Sine and cosine always have the same domain. Always all real numbers. Cool. What's the range? Beautiful. Square brackets because it hits and includes those points. Small number to big number. Gorgeous. Will that range always be the same for every cosine graph? Why not? Yeah. Think about these transformations. This is where we're going, right? If we move this graph down or up, or stretch it or compress it, doesn't that change the y values? Change the range. Cool. Good. All right. The period was 2 pi again. Yeah, this period is also 2 pi. Grab a highlighter or an extra color for me. I want you to trace this chunk of it again. Trace that chunk from 0 to 2 pi. That is the chunk of the graph that we kind of visualize when we think of one period for cosine. This is what I want you to visualize. It's like what I've got here on my little sign. Okay. This is cosine's graph. Okay. Everyone feeling good? All right. Before we go too much farther, I want to go back to sine, and I want to talk about some of the transformations, or maybe some of the properties, maybe that's a better word to use, some of the properties of this graph. Okay. So I want you, in this sine graph, draw this line in for me. It's right on the x-axis, and this is what I call the dividing line. Do you see how it splits the graph like right in the middle, top half, bottom half? They're like equal. Do you see how they're like evenly split? Yeah? This is what I call the dividing line. Go ahead and label that in your picture for me. Your dividing line splits the graph straight through the middle. Every sine graph has this dividing line right in the middle. Okay? And my question to you is to think about what would change that dividing line. Think about our transformations. Going up and down, like a D up and down? Yeah. If I move my graph up or down, wouldn't that change the dividing line? Exactly right. This D value, even though I know we haven't like talked about where these A, B, C's, and D's go yet, that D value is going to change your dividing line. Do we agree? Yeah? Where do you think D is in the equation for sine and cosine?
0.
In this one, it is at 0. Why do you think that?
Because sine rings plus or minus.
Exactly. D is normally that number that we add or subtract at the end, right? Well, if we add or subtract a number at the end, what is adding or subtracting here at the end? 0. That's the D value. That's why that dividing line is at 0 for the parent function. Does that make sense? Talk to me. Yeah? All right. Look at your cosine graph. He also has a dividing line. He has a line that splits him right through the middle. Is it up here at 1? No, his dividing line is right on 0 as well. That dividing line. Why was it at 0 for the cosine parent function as well? It's going to be that D value again, guys. Yeah? Think about where D is in the equation. Adding or subtracting at the end. Do we have anything adding or subtracting here at the end? Just a 0. That's why it's on 0. Does that make sense? Yeah? Okay. To be honest and transparent, dividing line is a word I made up. You won't find it in the textbook. I don't know if they even have a name for it in a textbook. Cool. But I really like that it starts with a D, because it's the D value that determines that dividing line. Helpful? Yeah. Okay. The other thing I want to show you is I want to point out how far up and down the peaks and the valleys are. Yeah, the tops and the bottoms. How far up and down they are away from that dividing line. How far away are these points here?
1.
They're up 1 or down 1, right? That is called the amplitude. Can you write this word down with me? The amplitude. And this parent function is a 1. Amplitude is how far above and below those points go. Cool? The amplitude. Okay? Connecting it to your transformations, Any guesses? The A value, think about where does A go in the equation? It multiplies in the front, right? What number is multiplying in the front here?
1.
A 1. That's your A. Cool? A amplitude, how perfect is that? A and A, yeah? The A value tells you what your amplitude is. It tells you how far above and below the dividing line those points go. Okay? Little thing, amplitude is always technically the absolute value of A. Okay, amplitude is always, that is a real vocab word. It's not a made up Miss Rose's word. Okay, amplitude is a real vocab word and it has to be positive. Always, always. Cool. Amplitude is always positive. Let's jump back up to the sine graph. How far up and down are we in this graph? 1 again. So the amplitude is again a 1. And that's because my A value was 1. There's like an invisible 1 in front of that sign, that A value. Making sense? Feeling good? Yeah, you're doing great, doing great. All right. From here, let's take a look at the bottom of our page. Has some vocab here, even and odd functions. We learned those vocab words back in Unit 0. Can you pair up or maybe even quad up into groups of 4? Try to remember what is an even function, what is an odd function. Discuss. I know that's 1 and 1 and odd and you. Yeah, so I don't know which one and the other one from the flip. And it's the same. Anybody think they have it figured out? Anybody remember either one of them? Malcolm, an idea? Say that again. They have 180 degree symmetry. Is that what you said? Yeah. Yes. Do you remember what kind of symmetry we call it? Starts with an O. It's called origin symmetry. Origin symmetry, which does mean it rotates 180 degrees around the origin. Odd symmetry, or an odd function, means it has origin symmetry. It rotates 180 degrees around the origin. If you want to put a picture to that, maybe a little example for yourself. A good example of that is an X cube. Remember those discos? Yeah. That has to cross through the origin, and the bumps on both sides have to be the same. So it has to be like as much up as it is down. Has to go through the origin there. My pictures are never perfect, but the idea is if you take your picture and rotate it 180 degrees, again, my pictures are always terrible. It should be exactly what you started with. Okay, that's what origin symmetry means. You rotate 180 degrees and you get the exact same picture you started with. Cool? Good job. That's the one most people don't remember. Good job. Anybody remember what even function is? What the other symmetry is there?
It's when you fold your paper in half, it's the exact same.
Exactly. Fold it in half along the...
Y.
Perfect. Good. This is y-axis symmetry. Meaning it folds along the y-axis. The left side mirrors the right side. A quick picture for that. Oh, how about a parabola like we did in our homework? We have a parabola right on the y-axis. And we fold this guy along the y-axis. Do you see how this point is a mirror image of that point? and this one mirrors over here, and this one mirrors over here. Yeah, that's a y-axis symmetry or an even function. Cool? All right, so do me a favor, look at the two graphs we drew for sine and cosine. Is sine even, odd, both, neither? Is cosine even, odd, both, or neither? Talk to your partners. Or your group of four if you prefer. Minimal conversation. What are we thinking?
Sine's odd, cosine's even.
I think sine is odd and cosine's even. Let's start with cosine. Even's usually easier for me to see. So even means I fold it along the y-axis. Does this point mirror over to that point? And this one mirrors over to this one. They're like the same distance left and right? Yes, good. This is even. It's an even function. If we rotate it 180 degrees, is it also odd?
No.
We don't think so? Let's try it. I take this, rotate 180 degrees. Oh, does that match up with the green line? No. Cool, so that's definitely not odd. Good. All right, let's talk sine. We think sine was odd? I think you're right. Let's try it. Whoops. Undo. Too many colors, too many things happening. I trace it and then rotate it. Is it exactly the same? Yeah, do you see it? Rotate 180 degrees, it's exactly the same. Cool. So good job. This one is odd. Is he also even? No, he is not even. Let's take a look at that. So like, does this point, he's like a little bit away, like what, 2 blocks away? Does he mirror over to this point? Down here, we need to mirror like this far away. Is that a match? No, so it's just odd. Make sense? Yeah. Bonus question, thought-provoking. Are all sine graphs, like even with transformations, would they all be odd? Yes? No? Other votes?
Yes.
Yes? Okay. It's hard to explain why yes. Do you think no? Why do you think no? Yeah, so if we have a C or B or even like an A or a D, right? Let's see. If this is my original, yeah. If I take that graph, let's do a D. Yeah, that center line, that dividing line goes up. Yeah. And I rotate this orange guy around the origin, meaning I have to rotate it all the way, flip it upside down. Yeah, think about like standing on your head, doing a handstand. If I look at that graph upside down, is it still going to be the same graph? Is it still up 3? Where will it be if I turn this upside down?
Down 3.
It would be down 3. Do you see it? Yeah? So that would not be always odd. Does that make sense? The parent function is odd or even for cosine. But as we do transformations, sometimes the even and odd gets lost. Or gets dropped. Cool beans? Yeah? All right. Would you please take a quick stretch break? Come grab this pink paper for me. Grab one for your neighbor if you're feeling generous. Maybe stretch break. So we're going to do the pink one together. The orange one is for you to do as you're studying and reviewing. Cool? All right. So can you guys also have this handy? This is the homework from last night. The back of it. All those transformations. want to start in the middle of the back of this page. Does anybody need an extra copy of this? Dawson, do you have it? Anybody else need one? So what I want to do in the middle is I want to show you what does the equation look like with all the A's, B's, C's, and D's for sine and cosine graphs. And a lot of this you already know. It's just like applying things you've already done with squares or square roots or logs. Where does everything go in a sine and cosine equation? So, start off with a little y equals. Which transformation, A, B, C, D, which one do you think goes in front of your sine? To A. Cool. So on the back of your homework, do with me. I know you got your pink sheet nearby too. We're going to put that A in front of your sine or cosine, whichever one it is. Cool. Back of the homework from last night. Who goes inside the sine function? B and C, both of them do. Yeah, just like B and C went inside here, inside of a square root or inside of a log, B and C are going to go inside the sine. Okay. Remember, we usually factor out B to CRC. Remember those words? So I'm going to have B factored out so that we can see RC. Cool. And who's the one that gets added or subtracted at the end?
D.
The D. All right, so our focus today is really about the A's and the D's. Okay, next class we're going to do B and C and things get a little messier. Okay, today hopefully A and D is not as hard. Okay, let's start with D because he's my favorite. Yeah, D is going to take your graph and move it up and down. And we already said what made up vocab word is going to change when I move the graph up and down. The dividing line. Cool. So in your notes page, or sorry, on your homework page, the D is going to change your dividing line. It moves the entire graph up or down. Cool? What do you think that A is going to change? That amplitude. That's exactly right. Great use of that new vocab word. Okay? Absolute value of A is called the amplitude. Amplitude. Okay? It's that vertical stretch or compression. It's still the same idea. It just has a new fancy vocab word. Okay? That amplitude, if you want to write kind of like a definition for it, amplitude is your distance from the dividing line. Your distance from the dividing line. How far up and down those peaks and valleys are. The tops and bottoms of those hills. The amplitude is how far they are from the dividing line. Remember, amplitude is always positive. Okay? That's what your A value does. Is it does that vertical stretching compression. Cool beans? Yeah? All right. So, when we go, now we're onto your pink sheet. When we go to graph these guys by hand, okay, without our calculators, what I want you to do is I need you to have a strategy for you, and it's cheesy and annoying, so don't make fun of me too much. It's called DAB. You know, just like the clip art guy's doing, right? It stands for dividing line, amplitude, bookends. Okay, dividing line, amplitude, bookends. And I'm going to teach you, talk you through this strategy. And it's a little bit tedious and annoying, especially today, because the A and the D is not so hard. Okay, but when we get into the B's and the C's, by doing this DAB process, you're going to be able to have good habits when we get to the B's and C's next class. Okay, all right. So the beginning starts with, you have to know the parent function. You have to know what the shape looks like. Okay? So when I say sine, boom, this is what I want to pop in your head. Just like when I say x squared on last night's homework, you knew it wasn't a V. What was x squared look like? A U shape, yeah? Okay? you know that sine, boom, looks like this. Okay? So on your pink sheet, let's draw this together. I want you to think about, it has like a dividing line through the center. Yeah? And I want you to think of sine as 5 points. Okay? Look here on my picture, 5 points. The first one's here. It starts on the dividing line. The first point in sine starts right on the dividing line. The next point goes up above the dividing line. The reason it goes up is because sine is normally positive, so it goes up first. Does that make sense? Okay. Your next point will be like up here. Cool. My third point goes back to your dividing line. Anyone want to take a guess where the fourth point goes? Below the dividing line, exactly right. It drops down to the bottom of the valley. And then your last fifth point closes out back right onto the dividing line. Those are the 5 points I want you to visualize when I say sine. Okay, if you're not drawing this on your pink sheet, you should be. Cool. This is what sine looks like, those 5 points. Okay. Also, you might want to label that the sine parent function goes from 0 to 2 pi. From 0 to 2 pi is original parent function. Okay. Today, they're all going to say 0 to 2 pi. Next class, the fun begins with B's and C's, and that's going to change where we start and end. Okay. All right, let's do a similar thing for cosine. Cosine has a different shape. This is what I want you to visualize for cosine. Okay. Again, though, how many points does it have? 5 points. There are always 5 points, all of these graphs. Cool? But this is the shape I want you to picture. Does cosine start on the dividing line? No. Who starts on the dividing line? Sine. Here's a strategy to help you remember that. Think about when you sign a receipt at the store. Yeah, you sign on the line, right? When your parents sign your report card, they sign on the line. Think of sine starts on that dividing line. Okay? Cosine's different. Cosine starts above. Yes, cosine starts above. Assuming it's positive, it starts up. Cool? That dividing line in the middle. Oops. When we get back, we'll finish. Cool? Have a good lunch. Let me see. Jonathan, Ricky, Carlos. Who else do I need? It's not even like 27 minutes. Yeah? Yeah? All right. So, looking quickly, we started right before lunch to draw like the picture of what cosine looks like on that pink page. Okay? I want you to visualize that dividing line going down the center on the x-axis. And then cosine always starts up above it, unless there's a reflection, then it would start below. And then your second point is going to be on the axis, or on the dividing line. Where's my next point? Down at the bottom, back to the dividing line, back to the top. Cool. So just like we have memorized what x squared, that U shape, or an eyebrow is a square root graph, right? We have that memorized. This is what I want you to visualize when I say cosine. Okay? And I had a student years ago. It was great. I said, Kyle, what does the graph of cosine look like? And he looks at me like this. Everyone look. He goes, I don't know. What does cosine look like? I don't know. Do you see what he did? Do you see? Yeah? That's the shape of that cosine graph. Cool? So if that helps you, that was my favorite thing ever. Cool? All right. We're going to skip B and C for today because we're going to do those next class. For now, I want to talk about DAB, and it's cheesy and annoying, but it is going to help you remember how to graph these lines, okay? What DAB is going to do is it's going to kind of create like a box. So you start with the dividing line, okay? The dividing line comes from which transformation? D. It moves that graph up and down, okay? So you start with that dividing line. It kind of like splits through the middle of the graph. You figure out where that is. Then you're going to do the A, the amplitude, the A value, right? The vertical stretch and compression, right? A is your vertical stretch or compression. Okay. What was the new word we called it?
Amplitude.
Beautiful. Amplitude is what we can call it for sine and cosine. Remember, that's always absolute value, okay? Always a positive when we use that vocabulary word, amplitude. What A is going to do is A is going to tell you how far above and below your dividing line you go, like how high up and low down those points go. Okay, so you kind of use those as guidelines. What would happen if A was negative? It would reflect. Yes, it would reflect over the x-axis. Good. And the last thing that DAB is going to do, the B, is called the bookends. And the bookends is where do you start and end the graph. Okay? So for a sine graph, and for a cosine graph, sorry, I forgot to label that. Sine and cosine both always start at 0 and end at 2 pi. So those are his bookends. 0 to 2 pi. Okay? 0 to 2 pi are the bookends. And what you're going to do is you're going to make yourself an inequality, a compound inequality with 2 inequality symbols. And in the middle, you put the bx minus c stuff. And today, we're not going to have any b's or c's, so it's going to be a lot easier. Okay? But next class, we're going to take whatever's inside that sine or cosine equation. We're going to take that bx minus c stuff and put it in between our 2 bookends and solve it out. Okay, we'll do more of that next class. For today, they're going to be 0 to 2 pi. And what those bookends show is it's going to show, I'm going to start at 0, I'm going to end at 2 pi, and you make like this little box. See how I kind of created like a little rectangle here? And that rectangle is going to show you where to put your 5 points for sine or your 5 points for cosine. Okay, it's by using this DAB process that we're going to practice in just a moment. Okay, before we get to that example, talk to me about the domain for sine and cosine graphs. Perfect. It's always all real numbers. They always go left and right forever. Cool. Does the range always say the same thing? No, we talked about this. You got to look at the graph, right? Remember, always go from the small number to the big number. And sometimes it's a bracket and sometimes it's a parenthesis. It depends on the graph. Okay. Bracket means it includes like a closed point. Parenthesis would be an asymptote or an open circle. All right? All right. So let's take a look at this first example here. We're going to try to do the DAB process on this equation. This is on the back of the white notes page. All right. Looking at that equation, it's cosine of x minus 3. It's a cosine graph. What kind of transformation does it have? This minus 3 is, say it again, down 3. Yeah, that's a D value. Does everyone agree? It's going to go down 3. All right. So to draw this graph, we're going to do DAB. D-A-B. D-A-B. DAB. The D stands for, what was the dividing line? And the dividing line, remember, is that D value, which was negative 3. So this D is negative 3 or down 3. So in your picture, you're going to draw a dotted line. It's just a guideline that says this is where the graph's going to split in half. This is my dividing line. Remember, the y-axis counts by a half, so you actually got to go down 6 blocks, all the way down to negative 3. Good? All right. Next up is A. What did the A stand for? Amplitude. The A is your amplitude. What is the amplitude of this equation? 1. Good, there's a 1 in front here. That's your A. So in your picture, you're going to make another dotted line, or actually 2 more dotted lines. 1 above the dividing line and 1 below the dividing line. Those are just guidelines to show you where those top and bottom points are going to go. They're going to be 1 above the dividing line and 1 below the dividing line. So like to -2 and to -4. Cool beans with me on that? Yeah? All right. Last part is the B. These are the bookends. Okay? Now the bookends for a regular original cosine graph, it normally goes from 0 to 2 pi. Agree? So you're going to start your bookends 0 to 2 pi. You're going to set up your inequality symbols. And in the middle of the inequality is where you put that bx minus c stuff. Whatever was like inside the sine or cosine equation. What was inside the cosine equation here? 1, what else? What letter's also in there? A 1x, yeah. The 1x. What about the -3? Is the -3 inside the parentheses? No. So it's just an x or a 1x on the inside, yeah? You're going to take that x and put them right in the middle there. And what that tells us is that our graph is going to start at 0. Put like a little vertical line here at 0. And it's going to end at 2 pi. Vertical line here. And that's making like a little rectangle for us. We started with the dividing line in green. Then we went up 1 and down 1 for the amplitude. Good. That's how high and how low we're going to go. And then the bookends, the 0 and the 2 pi, tell us where we start and end that 1 period. Okay, so we're going to have these 5 points in this rectangle. Does that make sense? Yeah? Okay. With these bookends, you always have to also tell me the tick marks. Tick marks is saying that we have 5 points total. True? We're starting at 0. We're ending at 2 pi. We want to know what are those 3 x values in the middle where those additional points go. Okay? So you're going to set up between 0 and 2 pi. There's going to be 3 more guys from the start and the end. There's going to be 3 more points in the middle. What are those x values that are going to come into play? Is this making a little bit of sense? So this is a lot. Yeah? And this is very tedious and annoying. Okay? But I have good news, because all of the problems today in our notes and in your homework tonight, they're all 0 to 2 pi. They're all going to have these same tick marks every time tonight. Okay? Next class, when we have B and C changing things, they're going to change. But for tonight, we're looking between 0 and 2 pi. Right in the middle would be what number? Pi. You want to figure out those 3 x values that are right in the middle between 0 and 2 pi. Pi would be right in the center. Who would be right in the middle between the bottom half here, between 0 and pi? Pi over 2. I agree. Pi over 2. Last one's the trickiest. Between pi and 2 pi, this middle here would be 3 pi over 2. Good. 1.5 pi is 3 over 2. Cool? So having those tick marks is important because that's going to show you where to line up the points. Cool? We are finally ready to graph. I'm sorry I always take so long. You ready? Here we go. Are we drawing cosine or sine? Cosine. Where does cosine start? Does it start on the line? No, it starts 1 up. Unless there's a reflection. Does this one reflect? No. So it's going to start at 0. It's going to be up at the top corner of that box. That top corner of that dab box that we drew. Cool? Our next point from there It's going to go on the dividing line, and it needs to line up with our next tick mark. It needs to line up with pi over 2. Pi over 2 should be on the dividing line, down at -3. Doing okay? Our next point, where is it in our picture? This one? Is it on the line? Below the line. Sorry, I misheard you. Yeah, it's below the line. So we're going to go at the bottom of the box. So line it up with pi. Don't just use the next rectangle or square in your picture. Line it up with that pi. It's going to go down at the bottom of the box at pi. Next point should be on the dividing line. Line up with pi over 2. Perfect. And then your final point at 2 pi should go back to the top right corner of that box. Gorgeous, guys. And here we go. We just graphed our first cosine graph with some transformations. How do you feel? Okay? All right. As you go to draw that curve, draw that wave, I usually ask you guys to draw 2 periods. Okay? Meaning I want you to continue that pattern to the left and give me a second cosine curve to the left. Okay? So think about it went up, down, up, coming back down, coming back up, all the way to the top corner. So continue those 5 points to give me a second period. I guess technically it's 4 points, right? Because the start of this one was the end of the last one. So you're continuing that pattern, drawing that cosine curve. To make your life easier, Ethan, you with me? If you want to highlight, especially for your homework tonight, you want to highlight that 0 to 2 pi dab section. That's going to help it really stand out to you when you go to check your homework. Cool? Super lightning fast. What's the domain here? Beautiful. What's the range? -4, -2. Brackets? Do we agree on brackets? Yes. Good. What about the period? 2 pi. Okay, that period being 2 pi means that you have only 5 points between the start at 0 and the end at 2 pi. You can only have those 5 points. Okay? Okay, math? All right. When you're ready, let's take a look at number 2. Is this guy a sine or a cosine? Cosine again. Woohoo! What transformation does this one have? A, yeah, it's going to reflect over the x-axis because it's negative. Good. Stretch vertical, stretch horizontal. Vertical, good. Vertical stretch by how much? 2. Make sure when you describe your transformations, you want to include all that vocabulary. Reflects over the x-axis. Don't just call it flip. Use the reflect word. And vertical stretch by 2, not just stretch. Okay, Matt? Yeah? All right, let's dab it. The D of dab was? It is 0. Good. It's that dividing line. Yeah? The D value here is a 0. So the center of the graph is going to cut right through at 0, right on the x-axis. What's my A value this time? -2. Technically, if I were to say what's the amplitude of this graph? +2, because it's absolute value. Yeah? You always want to, when I use that amplitude word, give me a +2. Cool. It does, though, reflect. So maybe put yourself a little note there so you don't forget. In your picture, draw that guideline in. Draw that up to and down to from your center line or your dividing line. Up to and down to. Those are just sidelines, but they're going to help you see where's the center, how far up and how far down do I need to go. All right, last part is the B. The B of DAB is your bookends. Your bookends. The original cosine graph starts at 0 and ends at 2 pi. So those are the original bookends you use, 0 to 2 pi. Set up your inequality. What goes in the inequality? Just an x. Good. It's the bx minus c part, which in this problem is just the x. Just the x. Oh, I can't see that. Yeah, just the x. So our graph is going to start at 0. Start at 0 and end at 2 pi. That's what we're looking at. We're going to draw 5 points, 5 cosine points, just in that box. You see it? Let's do tick marks. How many tick marks are there total? 5. Start at 0, end at 2 pi. 3 in the middle. Count the middle. Find the middle. Who's right in the middle between 0 and 2 pi? Single pi. Good. Who would be right in the middle between 0 and pi? Pi over 2. And last one between pi and 2 pi? 3 pi over 2. 1.5. 3 over 2. Those tick marks are going to be identical in all your homework problems to make too. Cool? This guy going much faster than the last one already, isn't it? Yeah. All right. Good habits. All right. Are we drawing sine or cosine? Cosine. Where does cosine normally start? At the top corner, yeah? Up 1 or whatever, yeah? This one is different. Why? It's got a negative. And it's got a 2, right? So that negative is going to cause it to reflect. The 2 is going to stretch it. So how far away should that first point be? Negative 2. It should be 2 down from that center line. 2 down from the center line. Does that make sense? Yeah. Line up to pi over 2 is your next tick mark. That next tick mark, that point should go right on the dividing line. Your next point is up at the top of the box, and that's at pi, all the way to the top of the box. 3 pi over 2 drops back to the dividing line. Couldn't say my words. And then last point, bottom right corner, below the dividing line. How do you feel? Good? As you draw your graph, remember to draw 2 periods. So continue that pattern. Continue that pattern for our second cosine graph. Or a second period, I guess I should say. Is that making sense? Yeah. I'm trusting you to handle domain, range, and period really fast. Check yours real fast. Negative infinity to infinity, negative 2 to positive 2 brackets, and 2 pi for the period. You know that? Yeah. All right. We got 6 minutes. Let's try to get to number 3. You want to try number 4? Feeling saucy? I'm feeling saucy. I think we go for it. You ready? Let's try it. See how it goes. Yeah? This one is a sine graph. What transformations does he have? Down 2. Good. That's your dividing line. Down 2. What else? Perfectly phrased. The A is 1/2. It's a vertical compression by 1/2.
How do you know what kind of compression it is?
Say that again.
How do you know if it's like a vertical or horizontal compression?
Great question. It's on whether it's an A or a B. So an A is what we're looking at today. That's going to be the guy that's out front of sine. Those are always vertical. Bigger than one stretch, smaller than one compress. Cool. Horizontal compressions and stretches we'll do tomorrow, or whatever.
Why is it vertical compression instead of just compression?
Because we have two types of compressions now. So there's horizontal compressions and vertical compressions. So you have to specify which one it is. Cool. If it's an A, it's vertical. Okay. Think about A and V. They kind of have that same shape to them, right? A and V. Yeah, that helps you remember that A is vertical, B is horizontal. Okay. All right. So let's do our DAP. Where's our dividing line? Down at -2. Gorgeous. Draw that in. We said the amplitude was just 1/2. So we're just going to go up 1/2 and down 1/2 from that dividing line. Up 1/2, down 1/2. See that? Doing okay? Bookends. 0 to 2 pi. The bookends are 0 to 2 pi. Put that x in the middle. It's just an x again. There's nothing to solve. Until next class. Yeah? 0 to 2 pi. Do you see that like box we created? Can you find me the tick marks? Hopefully you're feeling more confident and comfortable with those tick marks. They're the same on all of this notes and all of this homework. We'll do harder ones next time. Get excited. All right. I'm ready to draw sine. You guys ready? Yeah. Where does sine start?
On the dividing line.
On the dividing line. On the dividing line. So at 0, on the x-axis, you're going to start on that dividing line. Start at that down 2. First point, right here. Which way does sine go first normally? Up or down? Up. It's positive, yeah? What is it here? Is it positive or negative? It's positive, so we're still going to go up first. At the next tick mark, we're going to be at the top of the box. Okay? At pi, we're going to be back to our dividing line. At 3 pi over 2, you're down 1/2 below your dividing line. Gorgeous. Yeah, good. And at 2 pi, you're back on the dividing line. Repeat that pattern going to the left. Do your second period. Tridomain range and period. Notice how I'm continuing this pattern, coming from the right towards the left. It goes down and then up, and then down and then up. Cool. What would you say your range is here? -2.5 to -1.5. Awesome. Square brackets, -2.5 to -1.5. You want to do it in fractions, that's fine too. Cool. You guys feel okay? Yeah? Grab the homework on your way out. Great job today. I know this was a lot, but you guys did really well with it. So thank you for hanging in there with me. Have a great week.